We are live.
Excellent. All right.
Okay, I'll read question 3 when everybody's ready.
All right, ready?
In an ANOVA hypothesis test, we reject H when there is sufficient evidence to indicate that at least one mean is different from the others. True or false? True.
It's true.
Yep.
All right, I'll go. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply.
I put the data in each group are normally distributed and the variances are equal in each group.
Yeah, that's what I'd put too. I want sample means don't have to necessarily be positive.
Mm-hmm.
Agreed.
All right.
Okay, I'll do this one to check. If each group is normally distributed, do the following. I construct a QQ plot for each group.
Agreed.
Sounds good.
Okay, guys. I had to close and reopen, so if you want to read the next one, then I can grab the next round.
Okay.
Sure.
We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times the smallest sample mean, or each group has the same sample size. That one I have is B. The largest variance is less than 4 times the smallest variance.
Right, yeah, that sounds right. Okay. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1 to 2, 1 to 3, and 2, 3. How many pairs are there when there are 4 samples? Based on that, well, it seems like 4, right? Because it says if there are 3 samples, there are 3 pairs. Right. 2 to 1 to 3, 2 to 3.
Okay, but you have to compare every single group against the other. So 1, 2, 1, 3, 2, 3. We'll do those 3. Then you have to check each one of those against 4 as well, which will give you a total of 6 pairs.
2, 4, and 3, 4. Yeah, that'd be 6.
Yeah.
I think so.
I did write it out like a picture.
Right. All right.
So is it mine now?
Sure.
Oh, okay. The data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller numbers are more accurate. Okay.
Five types of shoes. Okay, so you got A, B, D, C. So there's 5 variables, right?
Mm-hmm.
So 6 groups. Also just wearing. Oh, so that wait, there's 6. There's
yeah. So there's one
also just wearing socks, right? Okay. Each row represents a kick from 10 meters away. Okay.
What's the first question again?
Minimum.
What is the minimum variance?
Okay, so we got to put all of them into the.
I'm looking at the soccer sheet and maybe I'm missing something. Oh, you have to
They're
scroll
all
down to get all
below.
the. Okay, it's just not lined up like chart is.
Yep.
Okay,
Like to throw you off.
but they do.
So the smallest variance, 27.208. That's what I've got.
One sec.
Yeah, I'm still working on it.
Yeah, me too. E.
When you guys opened the file, did it say it would like it can't be edited?
Oh, sorry. No.
Oh, mine
Well,
just told me it was locked for editing.
oh yeah, I've had that happen too. If there's another user in it, it'll lock it.
There shouldn't be another user, should there?
My guess is that somebody in administration's probably updating the file or has the file checked out for some reason.
Oh,
You
really?
can still view the file, you just can't make changes to it.
Okay.
Okay.
And you got 27.208 for your smallest variance, correct?
Yep, that's what I got.
That's what I got as well.
I'm almost done. I just need to go back and fix something. Let's see. Okay. All right. E. They have all these letters and then just socks. That's pretty great. Okay. All right, and then minimum. We have to do an individual cell function there.
No, you just look and see which one's the smallest of the variances.
Oh, there's the variance. Yeah, okay. Yeah, so 27.358.
I have 208. 27.208.
Wait, did you say
Oh, yeah,
358 just barely?
I
Yeah,
did. I said that, but
that
that's
would
the
just-
first one. It's not the third.
Yeah,
the
that's
third
just
one
the
is this
first
one.
group.
Right.
See.
The variance. They're not looking for the minimum. Okay, that makes sense. 27.208. All right. Okay, and then 9. Is that the 53 number? 53.158.
Uh, 53.158. Yes, that's what I got for the next one as well.
Cool.
And then the test for equal variances is satisfied for these data. And I have that as true because the smallest one is not, the largest one isn't 4 times larger than the smallest.
Right. That makes sense.
Now it looks like we get a good QQ plots. Woo.
So I think that this soccer one was in the homework.
Mm-hmm.
I did the QQ plots for all of them, and they were all pretty close to normal.
Yeah.
So then that would be true, right?
I'm double checking it real fast. It shouldn't take me more than.
Yeah, I think it's
Sure,
just
good call.
kind of meant for repetitive to give us more of a
practice with it.
Yeah. You guys know how to do the QQ plots, don't you?
There's that
It's on,
handy
yeah.
dandy one and the
Yeah.
quantitative descriptive statistics one.
Yeah.
It's that separate Excel sheet, right?
Yeah.
Yeah, I remember using that actually a lot in Unit 1. Or, Unit 1.
I actually used it for the first time with this lesson.
Didn't we use the QQ plots for like chapter... I don't remember what chapter that
I
was.
always
8?
manually created the QQ plots,
Oh, okay. Maybe I
so I was taking way
just
too
used it
long.
with something else.
Yeah, I looked at it and they're all approximately normal and just verified it.
Okay, cool.
Okay, so this next one says, perform an ANOVA test in SPSS and observe that the p-value is 0.081, then remove the SOX data and perform the test again. What is the p-value when we remove the SOX data?
3.09 or 0.309.
Mm-hmm. That's right.
Okay.
0.309, what you got?
Yeah.
I get 0.3081.
You deleted the SOX column,
Yeah.
variable 6.
Oh, I missed one of them, so yours is accurate. Got all but the very last datum
Oh, okay.
on that line. Okay.
That happens. All right. The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the F statistic?
It's to the right.
Right. Yeah.
Yeah, because that's the area of the tail, because it's non-normally distributed, it's right skewed.
Non-normally distributed is right skewed.
Well, it's a right skewed statistic for the F distribution.
Right. Okay, so the next one is researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat. Mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the spreadsheet. Use this data file to answer the remaining questions. Okay. Where do you guys go for the descriptive, where the Excel file is to plug all this stuff into?
Should be on the same page as the quantitative inference procedure.
Are you asking about the ANOVA page?
Yeah, the ANOVA page.
Yeah, it's on the quantitative inference page. I think it's 4 over or something, like the 4th tab.
Okay.
You know what I mean? And so for the next one, we use that QQ sheet again, QQ plot sheet.
This is, you're supposed to use the QQ plot for every data set to make sure that it's approximately normal when you're doing an ANOVA.
Okay.
I would say that for all three of them, it's approximately normal on the QQ plot.
Okay, I haven't gotten there yet, but I think so.
And yeah.
I'm sorry, and are they asking for the sodium? Or,
We're starting with calories first.
oh, okay, yeah, that's what I meant. Starting with calories?
Yes.
All right. Okay.
There are a couple of outliers with the QQ plot, but I'm only seeing like one per test.
Yeah, I've seen the same thing, but I've seen a lot worse be considered normal for the textbook.
Yeah. I mean, you have one outlier versus 10 outliers, but most of them
Yeah,
fall
it's as
in a
long as
trend
they have
line.
that trend.
I think
like
it
a-
was as long as they aren't a curve, then we're considered normal.
Mm-hmm.
We definitely don't have a curve. And the variances appear to be equal because you don't have one that's the largest as 4 times larger than the smallest. It's not even a variance difference of 100%, so much less 400%. So I'd say the assumptions have been met.
So
So A.
So a yes.
Mm-hmm.
a kind of a question that goes along with it. So it says construct QQ plots of the calories for each of the three types of hot dogs and compare the variances to determine if the assumptions you use ANOVA have been met.
Yeah,
But you
I
don't
plugged
know.
I plugged those three into the ANOVA test, and the variances are within 120 of each other, and the lowest one is 508. So they're definitely within the range for variances.
Right, but you wouldn't know that from the QQ plot. That's what I'm trying to get at. So my question is the first one or the second one?
Well, it says also compare the variances to determine. It doesn't say we have to do it just from the QQ plots.
Okay.
So we can also use the ANOVA
I would assume so.
page. Right. Assumptions have been met. Yeah, I mean, the QQ plots, they all look normally distributed. Should we go with that one? Or what else did you have to say about that, Aaron? Or did you say there's something?
Oh, well, so my question was is the question asking us to determine the variance from the QQ plot, or is it the variance from the ANOVA?
I can't tell from the way the question's worded. Sorry.
Yeah, we'll go with the first one. If it's
Right.
fix it as strong, I guess.
It seems like they're referencing the QQ plots to me. I mean, construct QQ plots, calories for each of the three types of hot dogs.
Well, if we get it wrong, we know it's the second one when it comes through the second time.
Mhm.
Okay. Yep. Good call.
Okay, question 15. Run an ANOVA test to determine if the mean number of calories is the same for all three types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F equals 16.074, and that P is equal to 0.000, the level of significance equal to 0.05. What conclusion do you draw?
Two and 51 are the degrees of freedom.
Gosh dang. I ran it off of the sodium one, not the calories.
Yeah, it's the calories.
So I've got a p-value of 3.8620 to the sixth power, to the negative sixth power.
Yeah, so it's super small. And so,
So in that instance, we're just calling it 0.000.
yeah, that's why they're calling it 0.000, because if you round to the third one, it's still 0.
Yeah.
I would say that we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type. So the last one. The assumption, the null hypothesis is that they're all the same.
Mm-hmm.
All the means are the same.
Mhm.
So,
Yeah, I would agree with that.
Yeah, likewise.
ooh, now we get to do sodium.
Yes, we've been waiting for that.
Yeah, I want to see how bad my health is going to be, right?
Yeah. Get a free little consultation right here. It's fantastic.
At least as far as the cube plot goes.
Mhm. For 15, we put the first one, right? Did we say that, or we pick another one? I'm sorry. I was just going back over it.
Which one's that one again? I'm not
The 15, the one where they give you the degrees of freedom and then ask you what the conclusion you can draw.
Oh, the last one, I believe, where at least one mean is different.
Mhm.
Oh, okay, yeah. That's right. Okay.
What? Poultry doesn't seem to be normal at all.
What I was thinking too. It's got a pretty good gap.
It's got a pretty good gap, yes, but does it have a significant curvature to it? That's what I believe is the big question. And I definitely am seeing the gap, but I'm not really seeing
All right.
a trend of curvature.
What was the other requirement then? It was to use the ANOVA.
The variances.
So the
Or it have to be four
variance
times.
doesn't qualify it. So 16.
Well, the smallest variance is 7180.75, and the largest is 10492.871. So the assumptions for variance have been met, but we're not possible with the normal distribution.
So I would say it was the last one where it says the assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, and we cannot assume that the variances are equal.
Okay, explain why it would be that one instead of the one just up where we can assume the variances are equal.
Well, I would say it's not safe to assume each group comes from a normally distributed population because poultry itself isn't normally distributed.
Yeah, and that number 3 is it's not safe to assume that each group comes from a normally distributed population. But it says that we can assume the variances are equal because the smallest one is not 4 times smaller than the large one.
Yeah, you're right. So we cannot assume that the variances are equal because the smallest is not 4 times smaller than the largest. Yeah, you're right. So it's the second one.
Second one, I have the third one.
Yeah,
But we
I've got
can-
third one.
Oh, never mind. Wait. I'm just reading the questions wrong. I'm getting them mixed up.
No
It
worries.
is not safe. Yep, you're right.
All right, third one. Okay. That was 16, and now we're on 17.
Yep.
All right.
So despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine the mean sodium levels for the same for all 3 groups. And what is the p-value for this test? I get 0.179.
That's what I've got too.
Mm-hmm.
Okay, what conclusion can you draw about the mean sodium levels of all 3 types of hot dogs? Use a level of significance. Alpha is equal to 0.05.
So p-value is greater than alpha.
And so we don't have enough evidence to reject the claim.
Mm-hmm.
I would say it's the top one. We have sufficient evidence to claim that all 3 hot dog types have the same mean sodium levels.
Wait, so the null hypothesis is that all of them,
All
Are
means
the-
are equal.
all means are equal,
Yes.
and
Ultimate-
and the p-value when it's greater, it means that we can
that we keep.
accept the null hypothesis.
Yes.
Right. Okay, so that would make sense.
But
So
the
did you
question,
guys... I'll go for it.
the real question is do we say oh, no. We never can claim that it's a positive. We can only say that there's not sufficient evidence to reject the claim. So it's actually the second one, not the first one.
We do not have sufficient evidence to reject. Oh, yeah, then. So you either reject, you fail to reject it, or you reject the null hypothesis, right?
That equates with my remembering.
Right.
Sorry, you were asking something, Skylar?
Oh, I was looking at the number. I was looking at the F statistic rather than the p-value. So I thought you guys had said that the p-value was a different number. So nope, we're good. It was 0.179.
Okay, I'll go ahead and submit.
%. Or 0%.
Sweet.
Really?
Yep.
Oh, man, I called that. I'm just kidding. Good, though.
Well, what time do we want to meet? Do we want to meet tomorrow?
Tomorrow's
What
Wednesday.
day is that? That's tomorrow's Wednesday, right?
Yeah.
That should work for me. Yeah, around 9.
That work for everybody else?
Yeah, 9 o'clock works tomorrow for me.
Okay, let's go ahead and plan on that one. And thank goodness we don't have to record this thing because it's supposed to be pretty long.
No kidding. Did you guys see too on the instructions that it said we can complete it by ourselves, but we don't necessarily have to?
Yes, I like the group consensus. It helps me learn better.
Definitely, me too.
Anyway,
One quick question. It looks like I got number 9 wrong. What was the answer on that? I have 153.158.
you said for
Number
9.
Yeah,
It's 53.158.
not 153. Okay, why did I
Not
put-
153, just 53.
Okay, all right, cool. Okay, all right, thanks.
Do you want me to read those off to you?
I think I can pull up the other submission, so it should be okay, as long as I just have that